All right, let me run through the formula sheet on this. Let's see how fast I can do this in, because I have a time constraint of 15 minutes on YouTube. Here we have a sampling distribution. Now the central limit theorem only applies to sampling distributions. It doesn't apply to anything else. Therefore, we need to know what a sampling distribution is. It's a list of sample means from many samples of the same size. So basically, instead of going out and taking a sample, we're going to go out and take like 12 samples. One sample's not enough. We need 12, 20, 100. And the reason you take so many samples is you want to limit random chance error. In other words, it's possible to go out and take a sample, do everything correct, and just because of random chance, you end up with a mistake in your sample. Now, we want to limit that sort of thing. So one way to limit that sort of thing is to take multiple samples of the same size. But once you find those multiple samples of the same size, what you do from there is you find the average of each sample and list them. So the sampling distribution is a list of sample means. Another way to say it is a list of all possible statistics, because the sample mean is a statistic. Over here we have the central limit theorem in words. It's unbiased. In other words, the population mean will equal the average of the sampling distribution. Now, to make sure everyone understands this, capital X bar is the average of the little x bars. Okay? A little x bar is one sample average. Alright? So capital X bar is average of all the x bars, little x bar is one sample average. Standard error, this is taking the population standard deviation and dividing by the square root of n. I didn't realize that was written poorly. I'll have to fix it. And part 3 says, if n is large enough, the sampling distribution will follow the normal. Now there's some theory that goes with this, and I got the theory at the bottom of the page. So if the sample size is large enough, the sampling distribution will follow the normal. What that means is, irregardless of the shape, whether it's normal, skewed, uniform, or irregular, as the sample size approaches 30, these things all tend to approach bell curves. Okay? So that's kind of a good thing. The other one, standard error, says as my sample size goes up, the variation reduces. In other words, my standard error gets smaller, which renders the results more accurate. Now down here we have numerical and categorical, because the central limit theorem can be applied to both kinds of data. Remember, it's numerical if it has a mean, average, or standard deviation. If we have any of those three, then it is numerical, and we know we're following the central limit theorem. Okay, I'm sorry, we know it's numerical and we're going down the central column. If we don't have any of those, it's categorical and we're going down this column. Alright, just a quick run through on the formula sheet. I'm going to keep it handy. I'm going to refer to it constantly as we work through this. Alright, now up here at the top, our first problem says, how would you describe your own physical health at this time? Would you say health is excellent, good, only fair, or poor? If the true proportion of people think their health is good is p equals 0.78, how many people must we sample to make the sampling distribution sample portion approximately normal? Now that doesn't say mean or standard deviation anywhere. It gives me p as 0.78, so this is categorical. And if I look on here and go down to the categorical side for normal, n times p and n times 1 minus p both have to be bigger than 15. So we're going to use that to solve for n. So n times p has to be greater than or equal to 15. So n times 0.78 has equal 15. So n equals 15 divided by 0.78. So if I get Mr. Calculator here and type that in, 15 divided by 0.78 comes out to be 19.23. And you always round sample size up, so we're going to use 20 on that one. We're doing n times 1 minus p equals 15. So n times 1 minus 0.78 equals 15. So n equals 15 divided by 1 minus 0.78. And n comes out to be, on my calculator, 15 divided by 1 minus 0.78. Comes out to be 68.18. Which rounds up to 69. And you pick the big one, so the answer is 69. Okay, you can also find this problem if you look under the list of sample size problems. It is the second one on that list. So when is 30 not large enough for the sample of a large enough sample for the sample statistic to be approximately normal? In other words, when is 30 not large enough for our sampling distribution to follow the normal? When it has at least one outlier? Well, most of the time we end up using t, and one outlier isn't affected so much by it, so I'm not worried about that. But if we have more, that could be trouble. Well, the population is highly skewed. Now, that's more trouble than only one outlier. So, yeah, we might have to use more than 30 if we're highly skewed. What if the population proportion is 0.7? So p equals 0.7. N times p, and we're talking about 30 here, is 30 times 0.7. And if I get my calculator out, that's 30 times 0.7. It comes out to 21. That is greater than or equal to 15, so that's okay. But if I do n times 1 minus p, that's 30 times 1 minus 0.3. That comes out to be 9, which is not greater than or equal to 15, and that's bad. Okay? So that one's also okay. Alright? So it's B and C, so it's 2 of the above. Alright, for this bottom one, a parameter is a population value. And a statistic is a sample value. Okay? Now, when I go to read this, it says, suppose the systolic blood pressure of American adults follows a right skewed distribution with a mean of 120, a standard deviation of 90. These are both parameters because it says for adult Americans. It doesn't say anything about from a sample. Now over here we're going to take a random sample of 100 adults. And the mean pressure is 128. So my statistics are going to be 128. My parameters are going to be 120 and 90. Alright? Now sample size is neither one. Okay? Sample size is neither one. So the sample size of 100 right here, that's nothing and we can ignore it. Because it doesn't come from the sample and it doesn't come from the population. So my statistic is 120. Did I miscopy that? 124. Oh boy, I miscopied that. It's been one of those days. So my statistics 124. My parameters 120 and 90. So that comes out to be D. Alright? So one page is done. Let's go on to the next page. Alright, now this is still related to that last problem. Up here it says, what is the shape mean of the sampling distribution of the sample mean? Okay? Now, there is a requirement for the normal distribution. The requirement for normal distribution is n has to be over 30. Okay? Now, this is numerical because the mean and standard deviation. So if we look at our cheat sheet right here, it says n over 30 for normal. Our n was 100. If we look back at the previous problem, I crossed it off, but n was 100. So we're over 30. So it's going to be normal. Now, one thing about this is this problem doesn't say normal in it. It says right skewed. Because of the right skew, I can't say exactly normal. So when I come over here, I can cross if anything says exactly normal. So I can't say exactly normal because I didn't start normal. Okay? Didn't start normal. I can't say exactly normal. Alright? Now, it did say n over 30 was enough to make it approximately normal, so it won't be that one, so the shape will turn to approximately normal. Okay? Now, if I look back at my cheat sheet here, it says the mean is the population mean. Remember, Greek letters are population means. So my mean would be the population mean, and the population mean on the previous problem, we have it written down, was 120. My parameter was 120, so my population mean is 120. So I'm going to come in here and look for the mean of 120. It says approximately normal, so the answer is E, not D. D's using the sample mean. Okay? So moving on to the next one. It says the college alcohol study interviewed an SRS of 14,941 college students about their drinking habits. Suppose that 50% of all college students drink to get drunk at least once in a while, that is P equals 0.5. What are the mean and standard deviation of the statistic P of the sample proportion who drink to get drunk? Okay, it doesn't say mean or standard deviation in the problem, so this is categorical. So looking at my cheat sheet over here, we're doing categorical, so we're going down this column right here. Okay, now my sample size is 14,000. I'm not going to need to check this for normal. That's well over high enough. So I know it's going to be normal. The problem doesn't ask for that, but that's okay. What we do get from up here is we have n equals 14,941 and p equals 0.5. Okay? And what I want from this is the mean and standard deviation. So going down this list, my mean is p. My standard deviation is the square root of p, 1 minus p over n. See, we're going down this column right here. All right? I'm off. Right here. We're going down this column right here. Now, because of that, there's a calculator program. Most of you probably figured that out by now. There's a calculator program for this because it's a little bit too much math for most people. We're going to push program. We're going down to PROP. Got to scroll for a bit because I got lots of programs on here. We're going to program PROP, so let me write that down. It's going to ask for the N and P that's up here. Little tiny bit off screen. There we go. It's going to ask the N and P up here. Okay. So I'm going to press enter by that program and start it. It's going to say input P. I type 0.5. It's going to say input N, 14,941. And it tells me the mean is 0.5. So my mean equals 0.5. My standard deviation is 0.0041. So my answer comes out to be C. We don't answer in percent, so we don't pick A. Okay? Now notice up at the top up here it says normal. That's checking the n times p and n times 1 minus p for 15. Alright? It's bigger than 15, so it works. Now, it does say press enter. What that's for is what if I wanted to find out if the probability in the sample we get an average of 0.51 or more. Okay? So I can press enter, tell it yes on normal. So we're going to type in the mean of 0.5, the standard deviation of 0.0041. We'll pick right end, and the shading starts at 0.51. And that will give me an answer of 0.0073. If the problem asks me to find a probability from the mean and standard deviation, we can do it by just pressing enter when it asks for yes. Alright? Alright, there's going to be a brief pause. I have to switch videos because I've got a 15-minute limit and we're approaching it.